Hello. So here is a simple example, imaginary example that you know the true mean and the true standard deviation. Then you can calculate how accurate a survey result would be. So the survey is on 100 random 100 people, and we are interested in the probability that the average underestimates the true mean by more than $3,000. So we are interested in this probability. Probability that the average survey average is smaller than $47,000 because the true mean is 50,000 and we are interested in underestimating more than 3,000. So lower than 47,000 is underestimation, bigger than 3,000. So we would like to calculate this probability from this information. Basically, only two numbers. We do not know any distribution. What is the distribution? But still we can do that. How can we do that? First, we can calculate the mean and the standard deviation of the sampling distribution first. The expectation of the average equals the expectation of a single outcome, like a income from one person, which is known to be $50,000. And also, you can calculate the standard deviation of the survey average equals the standard deviation of a single person's outcome divided by the square root of sample size, right? So we learned these two results from the patterns we find earlier, right? And then you know all these numbers, 50,000 and 10,000 divided by square root of 100, which is simply 1,000. So these are the mean and the standard deviation of the sampling distribution for the survey average, right? The survey average has this mean and standard deviation. And then additionally, we know that it follows a normal distribution. And what we calculated was the mean and the standard deviation, which are the parameters for the normal distribution. And we know everything about the normal distribution if you know its parameters. And we know everything. So then how can we calculate that? Remember, we have to standardize. We are interested in probability x bar smaller than $47,000. And from the property, the central limit theorem, we know that x bar follows a normal distribution with these parameters, mean and standard deviation. And then using those two parameters, you can standardize the probability. So x bar, you subtract its mean and divide by its standard deviation, right? And do the same thing on the other side of the inequality. Then the random variable becomes a standard normal distribution. And plug in the numbers, 50,000 here, 1,000 here. Plug in, then you get probability standard normal distribution smaller than -3 is the probability that we are interested in. The probability that the survey is underestimating by more than $3,000. And you can just find this probability from the table or Excel or calculator, which is 0.135%. This is an approximation, but this approximation will be very accurate because we have sample size of 100. 100 is much larger than like 35. So the approximation is usually acceptable. And we calculated the accuracy. So this is how we calculate the accuracy of an estimator or survey results, like results from random sampling. Later, the statistical inference is going the other way. We know how to calculate the accuracy. Then, using the result, we can think about what is the most accurate estimator. That's what we are going to study in the following chapters. So we are this chapter is preliminary and more preliminary purpose for the main inference methods. So it's pretty important. Um, so as I said, only from the mean and the standard deviation we can predict the accuracy, and that's the basis for estimation in the following chapter. Okay, I'm here is okay. Then I'll show you another example, another interesting example. This is like more toward economics rather than statistical inference. So I will show you the magic of risk pooling, which is based on the law of large numbers. So I will consider an insurance policy. Suppose your car insurance, the car insurance premium is $500 a year. Suppose you are paying $500 every year, say in January. And during that year, if you had a car accident, the insurance company pays you $3,000 once a year. Simply, if there is accident, you get $3,000. If no, nothing. You've just paid $500 but get nothing. And I assume that the probability of a car accident is 10%. So with 10%, you pay $500 but receive $3,000. And for the other 90%, you pay $500 but get nothing. This is the insurance, right? That is the insurance. That means if you understand how it works, then you can think about the profit for that insurance company. With 90% probability, the insurance company makes $500 profit from you. This is the premium you paid, but the insurance company does not pay anything to you. On the other hand, with 10% probability, the insurance company makes a loss of $2,500, which is a lot. Huge loss and like not ignorable probability. So this means if you take this at the face value, it looks like 10% of insurance companies have to go bankrupt every year, which does not happen, right? Of course, the probability and the amount will be different, but like a bankruptcy does not happen that often. Why? Here is the power of the risk pooling. I will explain what's going on behind it. Now, suppose that there are not only you, but 99 more clients to the insurance company. So, and I assume that the 100 insurance policy holders are independent with each other. So, your accident probability is not affected by whether the other policyholders are involved in an accident or not, right? Your accident does not affect the others and not affected by the others. And then I will define X as the profit from policyholder individual I, right? I is from 1 to 100. And we know we defined profit this way. So 500 with 90% minus 2,500 with 10%. That is the probability from a single insurance policy, right? So then the insurance company collects all the insurance policy holders and the average is what matters to that company. So X bar is the average profit from all of the 100 insurance policies the company sold. Now I'm going to calculate the probability that the insurance company makes a loss out of total loss out of 100 policies, which is defined in this way. Probability X bar, the average profit is negative, right? So then the company will make a loss. What is that? So try to calculate. So first have to do that is to calculate the mean and the variance of a single outcome, which is a single insurance policy holder. So calculating the mean and variance is simple because it's simple distribution. So we have probability distribution table like this, and pause the video, and if you are not confident how to calculate this, pause the video and try to calculate the mean and the variance. I will continue. If you so mean is easily 200. I believe you can calculate the mean. Remember, multiplying the outcome to the probability and sum them. That's the mean, which is 200. And the variance is calculated this way. First, subtract the mean and square that and multiply the probability. Then add all of the probability weighted square deviations, and you will get a 810,000 dollars for the variance. So the variance is 810,000, and standard deviation is square root, which is simply 900. I made up numbers so that the resulting numbers are simple. So the standard deviation is 900. By the way, if you do not understand how to get this, why we get this column, then please review chapter 4, where I explain how to calculate the variance. Okay. And then we just calculated the mean of a single policy holder. The profit, the mean, the expectation and standard deviation of the profit from one insurance policy holder, which is 200 and 900. But when you collect 100 policy holders at the same time, then the expectation and standard deviation of the sampling distribution become 200, which is the same, and standard deviation equals the standard deviation 900 divided by square root of the sample size, which is, so denominator will be 10, so cancel out, and then 90 is the standard deviation of the sampling distribution. And then you know everything about the sampling distribution, because by the central limit theorem, X bar follows a normal distribution, and the parameters are just calculated. Parameters are 200 and standard deviation 90. 90 squared, the variance is 90 squared. Therefore, you can calculate that probability. We wanted to calculate the probability X bar smaller than 0, which is the probability of a loss. And you have to standardize this guy by subtracting the mean and dividing by the standard deviation. So left hand side equals z, and the right hand side equals minus 2.22. So the probability of making a loss can be calculated as a probability of standard normal distribution. From a calculator or Excel or table, find this probability. Then you will get 1.313%. So now the probability of loss is only 1.3%, which is much smaller than 10%. So if you had only one customer, your risk is 10%. But when you have 100 customers, your risk is 1.3%. This is the power of risk pooling. You pool pull many risks uncertainties into you, and then they become insurance to each other. So in the end, the risk will be much smaller when you pool all of them. Okay, I'm going to continue. The next video will be rather short. I will finish the chapter in the next one. So I will consider this example a little. I will give you this question in the last second. So now consider what happens if you increase the size even more. So now you have 10,000 customers, 10,000, you sold 10,000 policies, and then what is the probability of loss in this case? Try to calculate that. I will see you in the next one.